probably mean we get way behind, but I like to do examples, so what can I say? So we have a little figure. It says in the figure, there's a particle, Q1 has a charge of plus 5e, so a positive charge, and it's located here at the origin. So 5 times the fundamental unit of charge, so evidently we're missing 5 electrons, or we have 5 extra protons, or whatever, in that little particle. And Q2 is negative 15e, and it's over here. Okay, and it says they're fixed in place with a separation of d equals 24 centimeters. So from here to here, it's d equals 24.0 centimeters. With electric potential defined to be V equals 0 to infinity. Again, they have to tell you where the 0 is, otherwise they can't ask you what the value is. Can't ask you what's the value of the box, the gravitational potential energy of the box. Why? Any number you like is the answer. Now if I tell you where the 0 is, I go, oh, the floor is 0. Now we all get the same answer. That's exactly what they just did. They told us that V was 0 out at infinity. Okay? So with V equals 0 out at infinity, what are the finite, a positive and negative values of x at which the net electric potential on the x-axis is 0? So this is, you know, where is the voltage 0? We played this game before. Only was, I think, electric, well, I think I did forces, but I think you had to do fields in the homework or something like that. Something like that. I always like to do this. I do the same thing, you know. Funny that. I like to do the same thing. I will look at it as 3 regions. And now the thing is, with the electric field, then we had to have that the forces had to be in opposite direction. The field had to be, the vectors had to be in opposite directions. But these are scalars. And so there is no directions, but we do need a plus and a minus. Because otherwise you get a positive potential from the plus one and a negative potential from the minus one. If you have a plus and a plus, they don't cancel. The only way they add up to 0 is out at infinity, and they don't want that answer. And if they were minus and minus, it's the same thing. So you have to have a plus and a minus to get them to add to 0. And then what we can do is we can jump to the second choice, which was that in order to get the, you know, for the electric fields, we had the magnitudes to be equal, then we needed them to be, you know, closer to the smaller charge. And so that's still going to be a thing. And which charge is smaller, Q1 or Q2? Q1. It's only 5e instead of 15e. Don't worry about that minus sign. That doesn't make it smaller. Okay. So Q1, so we need to be closer to Q1, and we do need positive and negative charges. Otherwise, they're not going to add to 0. Okay. And so what that means is there should be an answer in region 1, and there should be an answer in region 2, which is what they were hinting at with what's the positive and negative values for x where the potential is 0. And so what I always do is I go in and I label out, here's my point in region 1. And then what I'm going to do is I'm going to go in and mark off my distance from charge 1. So this will be R1. Now, usually what I like to do in these problems is I like to pick this to be a positive quantity. Okay, but they already use D. So I'm going to go with A. We could do L. If you like L better, you get to pick the little letters, whichever ones you like. I can go with A, because they already use D. Because I almost always use D. But they already picked it. So R1 is A away from charge 1. And what we get is that this will be R2. And so then R2 will be, you know, A plus D. Okay. And now what we can do is that in region 1, we can go in and run the calculation. And so this is the sum of the potentials is 0. So this is potential 1 plus potential 2 equals 0. This is K times Q1 over R1 plus K times Q2 over R2 equals 0. The K's drop, like they did with the field calculation. And I can put in that my Q1 is going to be plus 5E over my R1 is A, and Q2 is minus 15E over my A plus D equals 0. Now you'll see that the fundamental unit of charge drops, and there's a common factor of 5. Solve for A. So I probably would move this over to here, so I get 1 over A equals 3 over A plus D. Now, cross multiply. A plus D equals 3A. And then solve for A. Move this A over, so D equals 2A. So A is D on 2. D was 24 centimeters, so therefore A will be 12 centimeters. Okay. And then if we want the x coordinate, which is what they actually asked for, then since I know this distance is 12 centimeters to the left of charge 1 and this was at the origin, then what we get is that our x coordinate is going to be minus 12 centimeters. So there we go. So really not too bad. I mean, I think usually with the field and the force you have to worry about all the quadratics and nonsense like that. These aren't quadratic, but you have to do them twice. Because what will happen is when you do a field, then one of these regions will not work because the directions weren't opposite, but the other one does. So only one of these works when we do fields and forces and stuff. Okay. All right. So now what I'm going to do is I'm going to go into region 2, mark my point, and then what I need is I need the distance from charge 1, which I'm going to mark as A. And then this will be the distance from charge 2, which will be, D minus A from the picture. And then we go and we set them up. And I guess I'll just do it on the next sheet. Be okay. If I had written smaller, I could have gotten all on the one. It'll be all right. I'll write them all out. Usually what I do is I just set the absolute values equal to one another and go from there, but I'll write it out. It'll be okay. Minus KQ2 over R2. And at this stage, the K's go. We put in our Q's, put in our R's. Q1 was plus 5E. R1 was A, because that's the way I picked it. This is minus, and then this is minus 15E over this is D minus A. The minus cancel, the E's cancel, the 5's reduce, 1 and 3, and then I can cross multiply, just like we did before. So then I get that this is D minus A equals 3A. Move the A over. So D equals 4A. Divide both sides by 4. So then A is D on 4. D was 24 centimeters. So this is what, 6? And then my x coordinate will be plus 6 centimeters. Oops, sorry, y'all.